Hi everybody. Just wanted to make sure everybody's having a good evening or day or morning or whatever the case may be. I'm going to get started here in a second with some notes for section 11.4. Just thought I'd open some things up with a beautiful view that I get to enjoy out my back window every day. So today's section is 11.4, which is inscribed angle. What you need to be doing is taking notes on your own. You will come into class and you will actually work on the assignment during class tomorrow or today, whatever the case may be. So your focus right now is to take notes as if you were sitting in class. Make sure you take some good notes. If you get lost along the way or something you don't understand, what you can do is just pause and replay. Alright, so let's get started. This section deals with what are called inscribed angles. Now let me explain what inscribed angles are. Here's a good picture of one right here. An inscribed angle is an angle whose vertex is on a circle, not in, but on a circle, and whose sides contain chords of a circle. Now, we have talked so far about some central angles, and that was when the vertex was in the center of the circle. That was a central angle. What we're talking about here are inscribed angles, and right here is an inscribed angle because if you notice the vertex is on the circle, not in the circle. Okay? The arc that it is intercepting is this, well, that's called an intercepted arc. It consists of the endpoint that lie on the sides of an inscribed angle and all the points of the circle in between them. So as you see highlighted here, that arc right there is the intercepted arc of this inscribed angle. Now we have a theorem that goes along with inscribed angles called the inscribed angle theorem. Pretty witty. What it says is that the measure of this angle right here, this inscribed angle, is actually half of the measure of this arc. Now we have dealt with, again, these nice circle, these central angles. For example, if we knew that the measure of this arc looks like about 80 degrees, let's say. It may not be exact, but it's close enough. If this were 80 degrees, then the measure of this central angle would also be 80 degrees. Now, if I extend this angle maybe back here and actually have an angle on the circle, that's supposed to be straight, have an inscribed angle, as you notice, look at that angle right there, look at this angle right there. They are not the same measure. Specifically, this inscribed angle is half of the measure of this intercepted arc. So if we notice down here, to find the measure of angle PRU, I think we'll switch colors here, to find the measure of PRU, okay, which is here, angle PRU, that would be half of the measure of arc PU. Kind of smells. So this angle would be 59 degrees. Alright? Now, to find the measure of arc PS, if you notice, here's arc PS. Well, now, if you notice, this angle PRS has a measure of 27 degrees. Therefore, if that is half of the arc, then what do you think the measure of arc PS would be? Very good. And I hope you said that out loud and that everybody in your house is thinking that you're strange because you're talking to your computer. Alright, so this will be 54 degrees simply because this angle, the inscribed angle, is half of the intercepted arc. So that's 27 degrees, that is half of 54 degrees. Looking down here at finding the measure of arc ADC. Yes, arc ADC. Now notice we have to go in order here. Okay? Well, what we can do is, if you notice, and it might be tougher to see here, but if you're looking at arc ADC, notice that that is actually the intercepted arc for angle ABC. So if the measure of angle ABC is 135 degrees, then think about what that is half of, or better yet, let's think about the fact that we can double that 135 degrees, which would give us 270 degrees. All right. Again, with the same circle, if we are to find the measure of angle DAE, well, that's going to be half of 76. So what is half of 76? Very good. 38 degrees. I hope you didn't grab your calculator. You have a brain. Okay,